Thanks. So, yes, my name's Prash. I work for a company called Growth Intelligence. We're actually just 3 floors up. And I'm going to talk to you today about measuring the digital economy using big data. This is a novice level talk, I think. And really, it's going to be very focused on the application of what we've done. So how we've used Python and data to examine the digital economy and examine what that means. So in terms of what I'm going to talk about today, I'll give you some background into the problem and what we were actually trying to set out to achieve. Then I'll talk a little bit about our approach, how we used Python and data basically to achieve our goals. And then I'll talk about the methodology and the results that we actually achieved in sizing the digital economy, and I'll explain what that means in a minute. And then I'll also give you a few examples in terms of where these businesses can be found and what it means to be a digital business. So in terms of some background on the project itself, this was a research project that was supported by Nesta and Google. We worked, well, Growth Intelligence, we partnered with some economists from the National Institute of Economic and Social Research. We've been working on this for about a year now. We published a report last summer, which is available online. It's linked from our site and from NISA's site as well. And we are currently underway with some further phases of work. So we're still working on this project at the moment. So these were the 3 research questions we set out to answer. So the first one was about really understanding what it means to be a digital company. What does that mean? Trying to come up with a clearer definition, a clean definition of what that is. And then actually trying to count the number of businesses that fall under that umbrella. The second question is then trying to kind of dive more deeply into what it means to be a digital company and come up with more descriptive analysis around those businesses in terms of looking at some of the myths, I suppose, about digital businesses. So there's a kind of common conception that these are startups in Tech City, or that they're flash in the pan businesses and not really key to driving our economic growth. But that may not be the case. That may be the case. So it's really trying to understand what drives the growth of these businesses. And the third question is actually really about trying to understand what drives the growth of these businesses. So what's behind these digital companies? Why are they growing? Why are they innovating? And kind of trying to look at the causality here. So basically sampling the kind of present day data, looking back at some historic data and trying to link the two. What I'm going to talk about today is really the first question, because that's what what the report last summer was about. So why are we doing this? Well, the digital economy is currently quite poorly served by traditional data sets. So trying to come up with a definition of what is digital, industry, the government, everyone tends to rely on standard systems for classification and Companies House data. So Companies House is actually great. The UK is actually a leader in terms of the availability of data on businesses. But it has its flaws, and one of the main flaws being that it obviously only includes historic data. In terms of the standard classifications that are used to describe these businesses, so I should say there are about 3 million registered companies in Companies House, and it includes limited businesses and public companies and LLPs, so partnerships. In terms of how these classifications or definitions are used, I mean, they're pervasive in industry. So credit and risk decisions are made using standard definitions. A good example of this where probably, or rather a bad example of where this data was used, was in 2008, 2 of the leading credit insurers were basically stopped underwriting credit for huge swathes of businesses in construction. And they basically did this by sector, or by using this standard way of segmenting the market. And the reason they did this was because it was, post credit crunch, they were high risk construction companies. But really, this wasn't looking at the risk associated with the entity itself. It was simply saying, right, you're in this bucket, therefore, we're not going to provide you with credit. Also, government policies, obviously heavily driven by understanding the economy, and especially the agenda at the moment around the kind of digital Push and Tech City and things like that, and also things like tax breaks for computer games companies, and all sorts of policy decisions are made based on this kind of data. Trying to measure economic productivity, we're primarily a services-based economy now, I would probably, and that's quite difficult. In the past, manufacturing, you could kind of count the number of cars coming off a factory line, and you could say, yes, we're producing more as a country, and therefore you could have a fairly accurate measure of economic output. I don't claim to be an economist, by the way, so feel free to challenge me on some of this stuff. But clearly there is a challenge when trying to measure economic output of services and digital businesses. And I guess the last point, which is really, I should say, that's where our own bias comes in, is about trying to understand businesses who sell to other businesses use this data to try and segment the market. So you can imagine a bank who banks SMEs will perhaps give preferential rates for vets and construction companies, but not preferential banking rates for tree surgeons or something. And so it's quite important, basically, to come up with a good definition. So what am I really talking about? The current definition is that's used is called Standard Industrial Classifications, SIC codes. They were brought into being in 1948. This was kind of post-war. The government wanted to try and have a clear understanding of what the makeup of the economy was. Since 1948, they've been revised about every 10 years. The latest version was brought into being in 2007 and was adopted by the UK in 2008 and by Companies House in 2011. There are about 731 different SIC codes, so they're extremely detailed, but they're not without their issues, and the key issues are really the way in which they're generated. So when a business registers at Companies House, basically the business chooses themselves at that point. They self-classify, so they'll say, I fit into this bucket, I'm an oil and gas company. But clearly there's no real incentive for the business to get that right, and there's no incentive for them to change it if they change what they're doing. So, for example, a business founded 30 years ago as a hardware consultancy might be a web hosting company today, but there's no real reason they would have gone back and changed their definition. But this is the data that's being used by government and everyone. The other problem is actually, because there are so many different codes, it's actually quite hard for you to find the one that you best fit into. And conversely, because it's a system that's only really updated every 10 years, it's quite hard for emerging sectors to be represented. So, for example, there aren't really SIC codes to describe nanotech companies or fintech companies or any of the kind of emerging businesses. So this does mean that it's quite difficult to get a good gauge as to what the real makeup of the economy is. So this is just a bit of fun, really, but I picked out a few SIC codes that I thought were a bit more novel. So renting of videotapes, chimney sweeping. I didn't even know the UK did raising of camels, but there are about 20 companies that apparently breed alpacas. Striking of coins, so obviously the Royal Mint, I guess, needs to be classified. Dismantling of wrecks. I didn't know what the last one meant, growing, I don't even know how to say that word actually, but I think it's something to do with coconuts, so yeah. But the key thing is these last 2 points here at the bottom, which you might not be able to see at the back, but basically 10% of businesses are classified as other because they simply haven't been able to classify themselves in any other way. And 20% of businesses don't have an SIC code. So that's, about whatever 30% of 3 million is, a large number. This is again just to illustrate the kind of businesses that are in these codes. So I know word clouds aren't necessarily the best way to represent data, but I thought it would be interesting just to look at some of the businesses in the other category and size them by their revenue. So these are the largest turning over businesses. So you've got companies like ITV in there, Experian, which ironically provide credit data, Symantec, DHL, I think Chelsea Football Club were in there. Johnson Matthey, I think, is a chemicals company. You've got pharmaceuticals, Reuters. I think Canary Wharf Group might have been in there as well, actually, but probably best skim over that. So basically the point I'm trying to say is businesses that are classified as other actually do a huge variety of different things, and it really doesn't make any sense for us to be looking at the economy in this way. So this is the challenge we face. The digital economy isn't straightforward to define. What does it mean to be digital? You know, it really refers to not only a set of sectors that businesses may operate in, but also the kind of primary outputs that those businesses have, the kind of products and services they're producing, and also actually the kind of inputs they have. You could imagine a business that is wholly reliant on technology for its processing and its manufacturing or its value add being defined as a digital business or a digitally enabled business. So what this means is using a system that maps directly onto industries is always going to be imprecise. The government actually defines digital companies as being either those in ICT or producing digital content, and those map to a series of SIC codes, which I've got in an appendix somewhere. What we set out to do, basically, is therefore to say, actually, we think a data-driven approach will give us a better answer here, a better handle on the digital economy. So using data that's out there will provide richer, more informative, and more up-to-date classifications of these businesses. So how did we do it? How do we do it? So we have basically a huge array of different data sets that are linked back to businesses. So we start from Companies House, we take all of the registered businesses in Companies House, and then we link a huge number of other data sets, for example, news articles talking about the business, patents they've filed, trademarks they've filed, websites, so things like Wikipedia as well, obviously, but company websites themselves, LinkedIn, social media, all that kind of stuff. And we build up this related document set around a business, basically looking at all the words that are written about them and that they write about themselves. And we do this for all 3 million companies in the UK. Incidentally, we also can combine this with some of our client data, but to do slightly more novel things as well. So our approach is to define a different kind of classification system, a multi-dimensional system. So we still incorporate sectors. It makes sense, businesses operate in verticals. But we also look at the principal output of that business, so the product type, so whether that's a service or a physical good that they're producing. We try and understand what the type of client that they sell to is, so whether they're business-focused or consumer-focused or public sector-focused. And we also try and understand how they sell to businesses, their route to market, so whether they sell through projects or subscriptions or on a franchise model, whatever it may be. So this is just to illustrate why we've done that. You know, we think of this as a kind of, if I just look at sectors and products, so I've got sectors across the top and some example product types down the side. So the idea is basically you might be an oil and gas company that produces software, or you might be a telecommunications company that produces software, or an IT company, or you might be, you know, an oil and gas company that produces hardware, and then probably you're not really a digital business. But the reason we can do this is then we can come up with a more finer-grained approach to identifying these businesses. So how do we actually achieve this practically? So we take a very Python-orientated approach. We use Python extensively. So we have a series of crawlers and APIs. We use Scrapey, I'm never really sure how to say that, which is a Python crawler. And we also use a number of different Python scripts to extract features from crawl data and from structured and unstructured data sets. And then we also use scikit-learn and pandas, unsurprisingly, fairly heavily. It just lends itself quite well to feature engineering and classification problems. We build up training sets as well, using crowdsourced and pre-labeled data, and I'll talk a bit about this now. So I should have said earlier, we have about 140 different sector types and about 40 different product types, 3 or 4 different client types, and about a dozen different sales processes. So invariably, this means we have to build up a fairly large training set to actually come up with a decent sample to train our models on. So we use a few different techniques to build our training sets. We have employed kind of expert panels in the past to classify large numbers of companies. Also, from a sector point of view, it's quite easy to find some businesses that are pre-classified. So you can imagine a lot of public companies on the stock exchange are already pre-classified. Everyone knows what Vodafone does or what BT does. So it's actually quite easy to find some pre-labeled data for sectors anyway. And then we can also use crowdsourcing as a way of building our training sets. And this is basically, we'll set up a set of questions that people have to follow. So each company is effectively a job for them, and they will need to classify that business. So probably go onto Google or wherever and try and understand what the business does, and then classify it into one of X number of categories. Obviously, we need to put in place some kind of qualification questions around that to make sure we get good results. And we also use a majority vote to try and increase the likelihood of having correctly labelled data. So we look at a majority of 5. So that's training sets. In terms of feature engineering, as I said, we look at a number of different structured and unstructured data sets. So we look at news sources and website data. That clearly has its own problems. So when trying to extract free text from HTML, you'll have problems with badly formed HTML, or obviously just trying to strip out HTML and JavaScript and all that kind of stuff is also necessary. There are various Python libraries for doing that, obviously, things like Beautiful Soup and LXML, and a library called Goose, I think, which is used for article extraction. There are some Java libraries as well, like Boilerpipe, which is pretty good. And they all have their kind of pros and cons, really, and depending on the context in which you're trying to extract cleaned up data, it depends on which one you'll go for. I would say we didn't have great results with Beautiful Soup. It tends to be extremely resource hungry and tends to fall over pretty regularly. So I would favour something like LXML. And then obviously, once we've kind of generated these features, for a lot of our data sets, we're building bag of words type models. So we're tokenizing the data, we're calculating TF-IDF weights. Some of our more structured data sets, like patents and filings, we can generate features in terms of the classification of the patent, for example, or other things. And then in terms of actually modeling the data, so this is a classification problem, a supervised learning problem. We've got labels already. So we use scikit-learn, as I mentioned, purely because it just allows us to iterate very quickly on the data. We can try different models out, logistic regressions, SVMs, all that kind of stuff, all the good stuff. We actually opted for linear SVMs just because linear models are fast. We've got thousands of features. It works for us. And also, we found pandas tends to work quite well here because we can combine different feature sets quite rapidly, and they work quite well with scikit-learn. So we have typically sort of thousands of features. So this is an example. Scikit-learn is quite nice in that we can kind of examine some of the feature weights that have been learnt. So I've picked out for 2 sectors here, so computer networking and fashion. And I mean, this is just illustrative, but the kind of features in the bag words model that are coming out, switches, fiber, hosting, it's the sort of thing you would expect, basically. So the bars here are basically the feature weights. And for fashion, again, you've got things like clothing, fashion, accessories, bridal, nylon, hats. So again, the sorts of features you'd expect to see, which is good. So in summary on that element of it, we use multiple data sets as our input, and we find that allows us to get a better quality of result. We build multi-class classifiers for sector type, product type, client type, and sales process. And we then apply these classifiers to the 3 million companies in our system to come up with a set of labeled data from which we can work. And that really brings me on to the actual problem at hand about then trying to understand the nature of the digital economy. So I should caveat this with some of the challenges we have and some of the assumptions we had to make. So I've said we look at 3 million companies. What we don't look at are sole traders. So there are a lot of sole traders out there, one man and his dog type businesses. So the IT consultant at home, for example, isn't necessarily going to be counted here because we can only track what we can start from, what we have a handle on. Some of the other challenges we face are around actually identifying where these businesses are. So when a business registers at a company's house, they'll provide an address as to where they're registered. That isn't necessarily always actually where they're trading or where their place of business is. So it could be the CEO's address, it could be their solicitor's address for small businesses anyway. So that poses some challenges. We have some ways of dealing with these, but it can pose some issues. One of the other challenges is actually around trying to understand the group structure of businesses. So unfortunately, just counting up all of the businesses in the UK and saying, yep, there we go, there's 2 million businesses that are digital, probably isn't going to work, because businesses are fairly complex entities. They'll own other businesses and have subsidiaries, have parents, be foreign owned, potentially have special purpose vehicles that have been used for investment purposes and that are temporary entities. So it's actually quite complicated trying to unpick the structure of a business. So again, we've done some things to deal with this, but it's not a solved problem, I would say. And lastly, I think the other point is counting businesses is one way of looking at the digital economy, but obviously another important measure is trying to understand how many people are employed in the digital economy. And trying to come up with an estimate of how many employees there, again, has its challenges. If you're relying, again, on companies' house data, then you're going to be limited because you can only sample. Not all businesses, basically, will be reporting their employee numbers, so it's hard to get a handle on that. So, what did we do? So, first of all, we tried to build a benchmarking sample from which we could start. So we wanted to start by really trying to compare against the existing definitions, SIC codes. So the goal of this stage was to try and build this benchmarking sample. So we only included businesses where we had both SIC data and growth intelligence classification data, which means when I said at the start 20% of businesses don't have SIC codes, that actually means we immediately excluded them in this element of the work. What we then did was to go through a process of cleaning up these businesses. So we only really were interested in active businesses. So we dropped businesses that aren't trading, that are dormant. So when a business is dormant, it basically means they haven't filed any or traded for the last year. So they haven't filed any turnover. We dropped dissolved businesses and also those going into administration, so those winding up. We also dropped holding companies. So those are potentially shell companies or companies that exist there for kind of accounting purposes, for example, or umbrella companies that have millions of subsidiaries. And then we tried to deal with this issue of group structure, as I mentioned. So we clustered businesses based on similarity of company name, some ownership information, some postcode information. So we were trying to find company groups, basically. As I said, that's an approach. There's more we could do here, I think. But then once we'd grouped these clusters of companies, we then only picked the highest reporting revenue entity, i.e. try and find the main reporting legal entity. And that left us with a benchmarking sample of about 1.8 million companies, from which we could compare SIC and growth intelligence classifications. So we then went on to try and identify these digital companies. So we made use of our sector and product type classifications primarily. And really, again, as I said at the start, the intuition behind this is to try and find digital businesses that are in digital sectors, but also producing what you might regard as digital things. So the first step was just to come up with a short list of these sectors and product categories, and then clean out any combinations that didn't make sense. So architecture firms, building web hosting or something probably doesn't make sense. So any kind of sparse categories or ones that weren't made sense were cleaned out. And then we simply, we counted them up and we divided them up into geographies and things, and I'll show you some of those results in a second. And as I said, the real aim was to try and include companies that are either digital producers, so for example, the architecture firm that produces CAD software, but exclude those that are firms that aren't really, termed digital in the sense that their input or output or vertical isn't associated with it. So these are our results. So the top two rows there are using the standard industrial classification measurement. So about 10% of businesses using standard measurements are deemed digital economy businesses. Using our measurements, we found 14.4%, so an increase of about 44% there, were deemed digital. And I should say this is probably our most conservative estimate because, as I said, we haven't included businesses that are classified as, well, don't have a classification, don't have an SIC classification, so that's 20% already. And we also have been quite restrictive in terms of the sector product categorization. So this was very interesting, and really it means there are about 80,000 businesses that haven't been accounted for that could be deemed digital businesses. So I'll give you an example. This is a company called Kelton Engineering. They're based in Aberdeen. They're the example I hinted at earlier. They are an oil and gas company. They produce software for monitoring oil flows, and they do some software consultancy as well. So our classification basically came out with oil and energy for their sector, computer software for their product type, businesses as their client type, and projects as their sales process. They were classified under the SIC system as other. So it's an anecdotal example, but it illustrates the point. And when I had a look at this one, I thought it was quite nice that on the website, the three key things, the fact they do software, oil and gas projects, were basically on their homepage. So it was quite interesting. So I mentioned we looked at where these businesses were based. So we looked at travel to work areas and we plotted them. And then we found, unsurprisingly, in terms of raw counts of businesses, the majority can be found in London. And then we also found there are large numbers of businesses in Manchester, Birmingham, Bristol, Brighton, Middlesbrough as well, actually, and the Greater South East. What was more interesting was when we looked at some of the densities. So we tried to account for local population density as well. So we tried to identify regions where they had a higher than expected number of digital businesses. And so we found, again, areas like Basingstoke, Reading, Newbury, the kind of corridor that you would expect, but also places like Poole and Stevenage. I suppose, again, you'd expect to see Brighton and Guildford on there, Cambridge, Oxford. But Middlesbrough, again, was quite an interesting one that cropped up. So what's plotted here, sorry, is the location quotient. So anything above 1, which is basically where all of these bars are above 1, implies a greater than average population density of digital businesses. So I've just basically gone and had a look at Guildford specifically. So I ran a query and pulled out the data for Guildford. So the numbers here are the counts in different sector product categories. So we've got products across the top, sectors down the side. And as you'd expect, there's a lot of custom software development, financial services consultancy, I suppose, IT consultancy, and anyone who knows Guildford also knows there's quite a strong computer gaming industry there. So they were also picked out, computer games in desktop. So I mentioned we had some additional work we did. We had some additional findings. We looked at some other descriptors about these businesses. So we looked at the revenue and revenue growth of these businesses. We actually found digital businesses tended to be faster growing than traditional businesses. And we also looked at employee levels. So both of these, I should caveat, as I said, this depends. We only had a limited sample of data to work with here. But again, we found that digital businesses using our definitions had a higher number of average employees than non-traditional. So in terms of further work, as I said, we're ongoing here. The next phase is really to try and understand the drivers and behind innovation and growth of these businesses, and to provide more descriptive analysis of these businesses. So we tag businesses as well with basically technologies, industry terms, people, organizations. So we have a very rich set of tags that we can associate with companies, and we want to use that to delve into more detail around what it means to be digital. We could also do a few other things. We may choose to do a kind of unsupervised clustering approach just to kind of validate, I suppose, the kinds of classifications that we've come up with and validate whether that makes any sense. The UK is planning on releasing more data, or VAT data, and more data on businesses out there, which might make it easier for us to actually extend this to looking at sole traders. And lastly, we want to look in Europe, and we want to try and apply this approach to France and Germany and Belgium, Italy, and just try and understand the kind of digital makeup of businesses there. And then, to compare countries, really. So that's it from me. I should say, as I said, we've got a number of challenges, and I suppose I'm allowed one maybe plug. We're hiring, so if you want to come and chat to me about working on solving any of these problems, feel free. But otherwise, if you have any questions, yeah, I'm open to questions.